All right, good morning.
Good morning.
Let's see here.
Good morning.
We should, this module's fairly quick. We should be able to knock it out in one day. So let's see, that's that. Okay. So basically just kind of a recap of this whole notion of paradigms and kind of a walk through different languages. The last assignment is a short report, similar in size to what you did before. It might take 3 or 4 pages instead of 2 or 3. A short report about a language that's not in the class. Try to pick try not to pick MATLAB or Python, right? Those are such popular languages. My goal is to have you explore and find out that there really is this wide variety of languages out there. So I've got this short list here, but there's better lists online, and people are always making these lists. What are the most popular languages today? Every year, different groups come out with what they think are the top 10 languages. This was random. I mean, it came up at the top of the Google search. So if you look at this and then, I don't know, I always see these annual salaries and I'm always optimistic. I always think they're a little overly optimistic, but Python, yeah, as you know, Python coming on strong. I bet a lot of you guys know Python or have played around with Python, even though we don't have technically a course in this that you would take. I think we started using Python in CS332, which no one in the engineering community takes. But it's, people are finding it to be really useful. It's really big in the AI community nowadays. JavaScript, now again, what's that used for? It's going to be used for the online online things, right? Anything that's scripting, script is a scripting language. Technically or traditionally, scripting languages are not compiled, although they can be. They are translated in real time while they're running. And it's so popular because it's a web-based thing. I don't know if PHP is in this list, but PHP is also a big one. And of course, Java and C#. C# and Java are pretty much identical. C# is used in a lot of Microsoft applications, and also, oh gosh, there's like a game making software. They tend to use that. There's a modeling software called Blender, and then it goes hand in hand with a simulation environment, and they use C# for their coding there. And then good old C, after all these years, still hanging in there, C++. Notice how a lot of these are built on top of C. A lot of languages are that way. They're called a language, but really what happens is you translate from the language to C, and then you run a C compiler. I'm not aware of Go, although, but Google likes to do their own thing. So I've heard of R before, but I have no information about what it's about. And there's PHP, yeah, and I've not heard of Swift. I would recommend for your report, these are really popular. Go to this page. I put the link in the notes. This page has got many languages. Y'all are too young to remember BASIC, probably. That's the language people my age grew up on. The old early computers had BASIC. And then Pascal, and then Fortran. But there's many languages in here. Whoa. And as you can see, like under compiled languages, again, this is just compiled languages in this grouping, so it's all different types. ML, functional programming language. Smalltalk is object-oriented. Simula, object-oriented. That was the first one. Here's Pascal, which is primarily an academic language. It's one that was used to teach people how to program back in the day. But there's Python. Delphi is somewhat popular. I've seen it mentioned before. Haskell is a very popular object functional programming language. So I would go through this list, pick something out that you like, and then do your report on that. So the point is, there are many languages. Obviously, we can't teach them all. The idea being, you know, now that you guys have had exposure to the procedural languages like MATLAB and C, and object-oriented languages like Java, and functional languages like Racket, the idea is you can pick up any other language pretty quickly. And again, you know what to look for at this point. How do I declare variables? How do I do assignment? How do I do if then else? How do I do loops? And then how do I do IO? And then when you get those, you at least know the basics of the language. And then each language is going to have some kind of clever syntactic sugar that makes them unique and makes it easier to do, say, some kind of a specific job. So they tend to get used in different communities. Java's still the #1 language that's implemented out there. All right, so what I wanted to do today, and one of the reasons that I didn't put up a pre-recording of this stuff is I wanted us to have an interactive class where we fill in these blanks. And then for every paradigm that you encounter, in order for you to really understand the paradigm, you should be able to create a sentence like this for that paradigm. There are all kinds of weird paradigms out there. Or I shouldn't say weird, that's judgmental. It's different than what we've been exposed to. So let me pull up my little friend notepad. If we start with this, how would you fill in these blanks? Now remember, think C. How does the language C view computation? What do you do when you're doing C? What are the steps that you're taking? What is the behavior of the software that you're creating? Step by step, exactly. And what are you doing step by step? Go back to the idea of a program store. If you have a program store and you go and execute an if statement, did the store change? Or a while statement, did the store change? What's the only way you can change the store? Maybe it's conditional, right? So what do you mean by maybe though? If I just execute just the Boolean test, did the store change? Just the test, right? No. And if I executed statements inside the if statement, let's say the test is true and I execute the true branch, but there's no assignment statements in the true branch. Maybe it's all output statements. Did the store change? No. So If then else statements in and of themselves don't change anything. How about loops? If I go through a loop, if I'm just doing again, I'm incrementing my loop counter. Oh, well, there's a store change, and I'm checking against my loop counter. That's not a change. But if my loop only contains, say, output statements, other than the loop counter, which is a throwaway variable, I haven't changed the store. So what are you really doing when you're doing a procedural language like C? What kinds of things did you have in C that you didn't have in Java? Memory management. Ah, very good. So and that's really what I want to focus on here is memory, physical machine memory. So really a procedural program, we can say views computation is something to do with memory. And it achieves it through step-by-step incremental changes to the memory. Screen management. Yeah. Okay, let's do a simple sort program. I start with a list that's unsorted, and I end up with a list that is sorted. The list is stored in memory, right? It starts out in memory as an unsorted list, and then it ends up in memory as a sorted list. How would you describe that process? Other than the fact that I can't spell. Do you buy that? Isn't that what you're doing? You start out with memory in some initial state, and it's a global memory, right? It's one unified hunk. You start out with memory in some state. You run your program, and then when you're done, your memory is in some other state, some final state. And the only reason you have output statements or print statements is so you can actually watch it change. And how does it occur? Does it change all the memory at once? No. How many memory locations can you change with one assignment statement?
Just one, right?
Just one, right. I shouldn't say iterative. How about repetitive? Because it might be recursive, right? So that's what's happening in the procedural paradigm. You're taking some initial state of the data, and you're performing some processes, and then you end up with a final state of the data. And you do it one step at a time, one assignment statement at a time. And the if then else's and the for loops and the while loops are just there to help you with in the case of the if then else, to turn on and off sections of code that you need to execute for that particular data set. And the loops and recursion are there so that you can repeat sections of code as needed for that particular data set, so that your program can be responsive to different data sets. But that's what's happening. You're changing the memory. Even if you're doing something that isn't, like sorting. Let's say you're doing, you have a bunch of numbers and you're supposed to average the result. It's the same trick. How do you get the average? You add up all the numbers and you divide by the number of numbers. You add up all the numbers at once? Absolutely not. You add them up one at a time. Incremental changes. And you keep, temporary variables that keep track of what the computation looks like so far. Incremental changes. Let's do the same for object-oriented. Think about a beginning and an end of a program or a computation in the object-oriented world. How is it different from the procedural? If you can't think what is there, what's not there? What did we lose from the procedural?
Depends slightly, but the biggest thing would be memory management.
Memory management, absolutely. And why is that? What was the #1 reason why the object-oriented paradigm, what's its #1 claim to fame?
I'd assume it's use of like classes and structures.
Right. But what's the purpose of those classes, right? What, in terms of data management, what's the #1 claim to fame there? Encapsulation,
oh, yeah,
right? Data encapsulation, right? And in order to do that, you have to hide the memory, the physical memory to some degree from people. So C, the programming language C, those of you that took that class, you have pointers and you have direct access to memory and you can allocate and deallocate memory. And that's great because you have so much control over memory. It's also what makes C so dangerous because that's how viruses work, right? They corrupt memory. But in an object-oriented paradigm, it's a little tougher because you're removed from the memory, especially in a language like Java, where you're running on a Java virtual machine, which is an intermediary between you and the actual physical machine. So we're losing memory. It's no longer about incremental changes to memory, but Miles is right, this whole idea of classes and objects, what's going on there? How do you view the beginning state and the end state of your computation in terms of objects? Yeah, Bryce, the managed memory often comes from things like garbage collectors and stuff like that. You've all took CS332, right? So you know what object-oriented programming is. Can you explain what you know? All right. So instead of dealing with a single thing of memory, what do we have? We have a collection of objects, right? Instead of having the procedural paradigm, we have one program and you start at the top and you go down, 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 down. And I know you're saying, oh, but Garfield, there's functions. Yeah, but all functions can be inlined, right? In fact, that was a compiler optimization that several of you selected. All functions can be replaced with the body of the function in the code, so it's still in line. So we haven't violated that paradigm. We've just made it more convenient. But it's one program. And then when you get to object-oriented programming languages, it's not just one file. I know there's header files in C, but again, you can inline all that stuff. It's not just one file. It really is separate files for separate classes and then objects made from those classes. And at the beginning of your program, right, again, how would you describe the difference from the beginning of your program to the end of the program? You do the classic zombies chase me game. At the beginning of the program, there's a lot of zombies. At the end of the program, hopefully no more zombies. You won. Describe that in terms of objects. What is that? What would that mean? Accessing different memory blocks for each object. Right, right. But let's get rid of memory because again, we're kind of one step removed from memory. But we're changing the attributes of those objects and maybe even the existence of those objects. So if I start out with 50 zombie objects and then I play the game, how many zombie, and I win, how many zombie objects do I have at the end of the game? No objects. So what do we really have here? Just in terms of objects, at the beginning of the computation, we have some kind of a global state or description of the objects. And then at the end, we have a final state or description of the objects. Maybe all the objects are still there, but their attribute values changed. So it's not about a transformation of a single monolithic memory. It's a transformation of object state. And I'm going to say global meaning all, not that we have global variables, because as you know, global variables are pretty much a sin in object-oriented programming. Right? Doesn't that describe every object-oriented program you've ever written? The zombies chase me game. I start out initially with me and a bunch of zombies, and I end up with either the attributes of the object that represent me tell me that I'm dead, or the attributes of all the zombies that I was going up against tell them that they're dead. So we have initially, instead of a memory state, we have object state, which is basically the attribute values of those objects. And how do we get there? We don't get there through assigning values to memory because we kind of thrown that away. We're into discussing about objects. How do the objects know that they should change their attributes? How does an individual object know that its attribute should change? Better yet, what's the classic way to change an attribute value in an object? Object.set, right. So every attribute has setters and getters. Why do you have setters for the attribute? Right, right, because the attribute is private. So you have to have a setter for it. And who uses that setter? That object or another object? Typically, another one. And who uses the getters? Why do you have getters? Access within the object or from other objects? Yeah, so that's what's happening. We have an object and other objects need to know the state of that object, right? So they get the value. Or other objects need that object to change something. And so they ask that object either to set the attribute or they ask that object to perform some method, right? Each object is composed of attributes and methods. And the methods, the non-trivial ones, the non-setter getters, the methods are the things where the object is actually doing its job. Well, the object never asks itself to do its job. Other objects ask to do its job. You walk into a store and the door opens automatically so you can walk through. That door doesn't open for itself, right? That door didn't ask itself to open. That door opened because you approached it, which is your way of asking to open. So in terms of objects, these objects are working with each other, right? You buy that? It's all about the interaction between the objects. And we kind of talk about that when we talk about object-oriented languages. Remember some of the early examples are always things like, oh, an object can be a car because a car has other objects in it, like an engine and tires and a steering wheel and seats. What makes a car work? All of those things have to interact with each other. The engine doesn't do anybody any good unless there's a transmission connecting it to the tires. And the steering wheel clearly doesn't do anybody any good unless it's connected to the steering mechanism for the tires. So it's all about interaction. You knew that. Now you know it, right? Now you can express what you know. You knew it because you've been creating programs that do exactly that. All right, you ready for the last one? That's a rhetorical question. What's the deal with functional? The strong hint is that it's called functional. Where's the other places that you've heard functional? In your programming classes and in your math classes. And the other hint, of course, it's based on the lambda calculus. Yeah, it doesn't remember anything, right? So we're not going to talk memory management, are we? Although, you know, when you get down to it, because it has to operate on a real world machine, people will talk about defining your recursive functions in such a way that you don't get a big memory footprint. But that's beside the point, right? Right, doesn't remember anything. Now again, we can do the define x equals, or define x, whatever, to do the bindings, but there's not really this sense of variables. There's not really this sense of incremental change. Instead, there was a sense of what? How would you describe this experience you've had the last couple of weeks in terms of what you were doing with these to build up a functional program? A lot of recursion. And what's recursion a special case of? Small functions using other functions, exactly. And there's a name for that. What's that called? Derives from the lambda notation is the most generic form to describe a mathematical computation. That was Church's goal, right? Can I create a system that encompasses all of the systems? Pretty lofty goal. Or we could say, right, we can have a couple different ways of saying that. I'm leery of saying mathematical only because then people want to say, yeah, but you can manipulate strings. Okay, you're right, you can manipulate strings, but manipulating strings in the largest sense is still a mathematical computation. Because remember what computation was? Mindless processing by well-defined rules. Now read through this for a minute. See if you'd like to edit it. See if you think we've missed something or put an emphasis wrong. I think I'm just going to put this as computation. Yeah. It doesn't talk about the machine at all. It doesn't talk about objects or memory. It's just pure mathematical computation. Any edits? Okay, then we can stick with this. Now, here's why I go through this exercise with you. Being able to describe these different paradigms in a one-liner like this, where you really have to think about, wait, in order to make this one-liner work, I really have to go through and think deeply about what's happening. You know, you guys have been programming for so long, some of you guys are excellent programmers. Do you know what you're doing when you're programming? You should, right? You should be able to consciously and explicitly express what you know. It helps clarify your thought. It helps make you a better programmer. My personal belief is almost any endeavor that you're in, you should be able to come up with a one-liner. Right? You're in the computer science program. What's a one-liner for computer science? You're in software engineering. What's the one-liner for that? What is that discipline? What's the core of it? I believe there's value in that exercise. It helps you stay centered on what you're doing when there's so many ways details can throw you off task. If you remember, you're involved in some software project and the details of it are driving you nuts, just remember, oh wait, we're using C Our only path forward is incremental changes to memory. So how can we make this problem work using incremental changes to memory? Now, these aren't the only paradigms. As we'll see on that other sheet, but you can create the same trick. How do I know? How do you know that you know something, right? This gets into that kind of esoteric question. How do you know when you know something? You know when you know something when you can explain it to somebody else. And this one-liner trick is a way for you to convince yourself that you can explain it. After the one-liner, let's see, the procedural paradigm views computation as transformation from input, initial memory to final memory. It does that through incremental changes to memory. After that one-liner, you have a whole course called CS332 or EGR 115 to explain that one-liner. But it captures all of the details of that. I believe there's value in that. When you're approaching a new situation, how do you know that you have enough information, enough knowledge and understanding of that topic when you can produce the one-liner? So when you're out in the real world, you're going to run into different kinds of computing. You're going to run into different paradigms, different languages. And my advice is, try to work up to a point where you can pull together that one-liner. Once you have that, then it helps guide you as to how to get through the details. There are non-procedural forms of languages, and according to that Wikipedia page, even functional languages fall into that domain. Non-procedural forms. There's languages that are logic programming languages like Prolog. Prolog starts out with an initial set of axioms. It's a logic programming, so axioms, and then it has a final state of statements that need to be proven. And that's the program, the initial state and the final goal state. And then how does the program run? It tries all possible logical paths to get from the initial to the final to determine if it's possible. Clearly not procedural. You are not specifying step by step by step. You're saying, hey, here's what I got, here's what I want, can I get there? And it goes through and does that's what that language does. There are languages, tuple space was starting to be popular in the early 2000s and then it died. And I'm wondering if it's going to come back. Tuple space is about a really bad way to describe it. It's about taking, instead of a single program, a single piece of execution of the code and representing it as a tuple. And then the way the program works is it just keeps randomly grabbing these tuples and saying, hey, can I execute you yet? And the tuple includes conditions like, in order to execute me, you need to know X, Y, and Z. Or you need to have permission from this other tuple over here. That's the if then else. And the computer grabs one at random and says, can I execute you yet? Nope, throw it back. Yes, execute it and put the new tuple, the new result back. Now that seems like a stupid way to run a program, and it is when you only have one processor, but what if you have 10,000 processors all grabbing at that bucket? It's a highly parallelized way to work. And when people were starting to get into massively parallel systems like we have today with the cloud, that was an attempt to produce a paradigm that would take advantage of that parallelism. It's not popular now. I think it might come back because of the way the cloud services run. Data flow languages are all about, it's similar in tuple space, but in architectural form. You can literally create a computer that has, where you're building the computer, instead of a program, you build the computer in such a way that each little chip in there can do one operation, and it has permission, and it knows what inputs it needs to do the operation, and it knows who is telling it that it's allowed to execute. There's your if then else. If you've ever looked up graphic processing units as vector processing, one data stream goes this way, one data stream goes this way, and they're going through a little processor that keeps performing some action over and over and over again. There's all kinds of different forms out there, and you may encounter them. If you encounter them in your professional life, they will probably not throw you to the wolves. They will probably ease you into it. But again, be aware of this kind of a sentence. Okay, so you want me to do effective programming. What's that about? Oh, effective programming views computation as, and it achieves it by. By the way, effective programming is programming that tries to take into human affect. So it tries to recognize human emotional state. And then the program can change its behavior based on the emotional state of the user at the time. Something that we all wish we had when we're hammering the keyboard in frustration. There's all kinds of stuff out there. So be aware in your professional life, you might work in a language that you're already familiar with. You might not. Throughout your career, I suspect you will not. You will be introduced to new languages and languages that haven't even been invented yet. But probably different languages than you're used to, maybe different paradigms than you're used to. These kinds of techniques can help you navigate all that stuff. How many of you guys have had an internship? A lot of you guys have had internships. How many of you guys have had an internship where you were exposed to a language that you were not exposed to in your academic world, where you didn't have a formal class on the language? And what was it? Ada, yeah. Now, and Ada came about, again, because prior, remember the history of programming, all these software projects got big, they got complicated, nobody knew what was going on. And people tried different techniques just to manage this. There's, structured programming techniques and block programming techniques. And Ada came along as a language that was inherently structured. And for a while, the federal government in the US said, thou shalt not receive a contract unless you program in Ada. And so there were a lot of Ada programs built in the 80s and probably into the 90s, and somewhere around the 90s, they figured out they still don't know what's going on because software engineering is intrinsically difficult. But those pieces of software are still out there and the language is still used. So new pieces of software are being built. Bryce, was it you were working on an existing project, I'm guessing, or was it brand new code, or were you modifying old code or attaching new code to old code? My guess is you were working with some legacy code. Yeah, and that's pretty normal stuff. In fact, at the heart of the DoD financial processing system is a piece of software that was written in, I can't remember, Fortran or C or maybe Ada. And it's been there for like 30 years and they want to get rid of it and replace it, but they're terrified to touch it because it's the heart of the entire system. So, they're worried that they're going to break it instead of fix it, but they would love to get rid of it and put a new more modern programming language in. That information is about a year old. So maybe by now they've done it, but I don't know. But that's the kind of fix you get into in the real world. Oh yeah, there you go. There you go. Was it avionics by any chance? A lot of some of the, yep, yeah, that was the thing. If you're going to build avionics for us, you have to do it in Ada, which is ironic because now I think a lot of people like to use C or C is a front end language that then goes into like an assembler and then maybe uses some lower level language inside the avionics these days because C is so tightly coupled to the hardware. But anyway, be aware that this stuff is out there. Because you have to do the program twice, right? One in a language of your choice that is not functional and one in functional. And that's why it's worth 80 points. It's 40 points per. I suspect being able, I'm losing my mind, guys. Intersecting rectangles. One rectangle, list of rectangles. $115, $130. I have to look at that. Is that in the root? Oh, wait, this is the parse. I'm sorry, this is the state machine one. Yeah, the finite state machine one. Yeah, so do a finite state machine once in the paradigm of your choice that's not functional, either object oriented or procedural. I suspect procedural will be just fine, and then do one functional. Need to write a parser, take regular expression in state machine format. Yeah, that's what that 15 and 30 points is about. So if you say, okay, I'm going to write a finite state machine to solve this specific language that I gave you, so I can accept all strings in the language and reject all strings not in the language, and then you're going to get the 15 points. If you want to write a generic, here's how you do a finite state machine, and we can do it again by changing data up front, or if you want to be sophisticated enough to do a data file, or you can do user input. So you can create any finite state machine. That's where you get the full 30 points. Once you do it for one, you will recognize that all that's changing is some, basically it's the transition table is all that's changing. So then you can create a transition table for any language. You get at most, what do I say, 15 points versus 30? Right, to get the full credit for the thing, create the ability to create generic finite state machine. Now, I don't care how ugly it is. In other words, if I have to go in there and, particularly for the functional, you're going to do definitions, and you're going to have some kind of a list that represents your transition table. And I expect that I'll have to go in and modify that, inside of Racket and replace it with a different one. No. We're talking about the one next week. Yeah. Yeah. Let's take a look at it. Let me bring it up. Yeah, it's out of 40. There we go. Oh, by the way, okay, so I'll accept submissions late. I'm not allowed to require that you submit during the study break. So I'll accept submissions late. So I made it early with this note, okay? So you make a finite state machine, and then on the right page, deliver the code, then some kind of a description. And the reason I need the description is because you guys are going to come up with different solutions and basically show that it worked. You can do just a screenshot of the input output. If you want to do the when you're doing your functional, you can just do a screenshot of the Dr. Racket. This is the non-functional one, right? This is about the problem statement. Typical, yeah. So this is the non-functional. You can do MATLAB, C, Java, Python. The reason I need you to demonstrate the code for me is because I may not be able to run on whatever you, whatever language you selected. And so I may not be able to run your code. So just, show me how it worked. Show me what worked. So the 15 and the 30, full points is 40 points. So 5 points for, hey, this thing just runs. 5 points for what does your code look like? And then if all you do is hard code that specific language, and I did it once if you wanted to use some people like to use alphabetic characters, so they like their alphabet to be A and B. Some people like to use ones and zeros, so they like their alphabet to be 1 and 0. And so I don't care if you do just that language and your machine is hard coded and I can't do anything to modify it, then you can get at most 15 points, which is what, 15 and 10, 25 out of the 40 points. If you go to where, okay, here's how you can modify it, right? And you do a generic finite state machine where either through user input, say console input, or file IO, or if you want to get involved with GUIs, that you're doing something with a GUI, if you're doing that, where we can create a generic finite state machine, then you get the full 40 points. And again, just demonstrate, okay, I created this machine, I created that machine, and here were the results. The other is to do the exact same thing, but with Racket. And here, if you want to code the generic machine, then you can again either do it while it's running prompt for the inputs, or you can do explain to me how to change the definition for the transition function. Right. But again, if I can't recompile your code, that's why I need you to demo it to me. Right. Ideally, if you're going to edit a state table, in the functional world, the way Dr. Racket works, right, with the definitions and the execution here, I can see that, right? You can show me, okay, here's my first definition, transition table. Here's my second one. And for the first one, here's here's where I tested my machine. For the second one, here's where I tested my machine. But for the other ones where I have to actually compile and run, show it to me. You're going to have to show it to me because I may not be able to compile and run your code. If it's in Java, if it's in C, I'm good. I can't remember if my Python's up to date, so I don't know. MATLAB, no. You think it through, it's not that tough of a problem when you think it through. And I know because we've done this in past semesters. Okay, I got to run. If you have more questions on it, throw it up in discussion page and or send me Canvas messages. I got to let you guys go.
Thank you.
Thank you.